Yeah, hi friends. Welcome to TMRM Art YouTube channel. Now we are in the next lecture. Okay, so today we will discuss on this geometrical configuration part. Okay, under the topic of principle of robotics and automation. So geometrical configurations of a robot refers to the arrangement and relative relationship of its links and joints, which decide the shape, size of workspace and type of motion. Okay. Basic elements are links, joints and end effector. Links, a rigid body or combination of rigid bodies. Okay. Like this, they are okay, these are links. So a rigid body or combination of rigid body, and joints are provides relative motion between two links. Okay. These are joints. End effector, at the end something will be there. Okay, the last link that interacts with the environment. So at the end, the last links that interacts with the environment, that is end effector. Now type of joints. So here type of joints here, revolute R. Okay, then a symbol like this, then motion is like DOF. Okay, one DOF it is there. An example is hinge. Then prismatic type also there, it looks like this, and its degree of freedom is like this. Example is slider. Now kinematic pair, a joint formed between two links having a definite relative motions. Okay, so lower pair and this is higher pair. Two types of kinematic pair is there. So here I can show you images. Okay. This is example of lower pairs. Okay. These are lower pairs. So here what is this, there large contact area is there. Okay, here you can see the contact areas are large actually, all these things. Now if you see this higher pair, then contact areas are very small, a tiny contact area, point or line. Okay, here, so contact lines are very tiny, so pressure will be obviously here high, because in a small area only contact is there, so pressure will be high. Now let's come to our topic. Now degree of freedom. Okay. Degree of freedom. So here the number of independent parameters required to completely describe the configuration of mechanism. Okay, for a special mechanism, here there is a formula, that is Greveler formula. Okay, so here m equal to 6 into n minus 1 minus summation of I equal to 1 to j f of I. So where n equal to number of links including fixed link, j is number of joints, fi equal to degree of freedom of ith joint. Okay, r or p joint degree of freedom is 1, we have seen in the previous lecture. So m the mobility of the mechanism. Okay, or the total DOF of the mechanism, you can see. Now common geometrical configurations of a robot. Okay, they are Cartesian, three prismatic joints, rectangular workspace is there. Okay, now cylindrical RPP, one revolute is there, two prismatic cylindrical workspace is there. Okay, now here the spherical or polar RP, two revolute, one prismatic spherical workspace is there. Okay, now articulated RRR, three revolute joints are there. Okay, three revolute joints are there. Now here the SCADA, so two revolute in same plane and one prismatic. Okay, it is there, which is vertical, so good for assembly tasks, this SCADA. Now important points are here. More degree of freedom means more flexibility, more complex control. Serial manipulators, joints connected in a chain, most common. Okay, so serial manipulators is like joints connected in a chain. Now parallel manipulators, multiple chain connected. Okay, and high rigidity. Now choice of configuration depends on task, workspace, payload, accuracy and cost. Okay, to maintain all these things we need like cost also. So these things we need to take care if we use this in our industry, this type of robots. Okay, so summary here, you can see again Cartesian, cylindrical, spherical, articulated and SCADA. These are type of that geometrical robots. Okay, so here joints here PPP form means all are prismatic, and here revolute prismatic like that, it is there. Okay, so spherical you can see, then articulated, then SCADA. So spherical and SCADA there is almost same, and articulated is RRR, and cylindrical RPP, and Cartesian is PPP. Okay, degree of freedom for all it is 3. Here Cartesian is rectangular workspace is there. Okay, so in rectangular area it can work, not outside that. And cylindrical, it has cylindrical area, limited cylindrical area, in between that it can work. Okay, and here spherical, also spherical sector workspace, articulated irregular complex workspace is there. Okay, and SCADA here cylindrical or annular workspace. Now Cartesian type of use is pick and place in CNC machine. Cylindrical it is used in assembly handling. Spherical used in arc welding or spray painting. Articulated used in general purpose welding, painting. Yes, SCADA used for assembly or insertion. Now gate level practical questions we can see. One, a special mechanism has 5 links, okay, including fixed link connected by 4 lower pairs. All are revolute. Find the mobility of the mechanism. So we can directly use this formula here. Okay. So here mobility of the mechanism asked. So here it is n equal to 5 and j equal to 4 lower pairs I mean contacts. So fi equal to 1, r joints are used here because for spherical mechanism 2r 1p is there. Okay, so just here think this fi equal to 1 here. Okay, r joint. Now m equal to, it will be 6 into n minus 1 minus summation of fi. This is the formula. So now here lower pair is 4, so I will go from 1 to 4. So 4 time we need to add this fi. So 6 into 5 minus 1 minus 4 into this fi means 4 times this, so it will be 20. Next, a mechanism has 4 links including fixed link. It consists of 1 revolute joint and 2 prismatic joints. Okay, find the DOF. So solution is here n equal to 4, j equal to 3. Okay, 2 p joints are there, so f equal to 1 each. Okay, revolute joint and 2 prismatic joints are there. Here it is mentioned already. So 2 p joints, f equal to 1 for each, and for r joint also f equal to 1, so there are 3. Okay, so it is 3. Now the formula we can use here again, 6 into n minus 1 minus summation of fi. 6 into n is 4 here, 4 links. Okay, now fi, if we do summation, there 3 links are there, so 3 for each degree of freedom 1 also, so it will come 15. Now a manipulator has 3 revolute, 1 prismatic joint. All the joints are lower pair. Okay, what is its degree of freedom? So n equal to joints plus 1. So here 3 revolute and 1 prismatic joints are there, so n equal to 5. Okay, 4 plus 1, this we can remember every time. Here also you see n equal to 4 and number of joints I mean number of links 5. That means joints are 4. Okay, 4 lower pair already mentioned. Lower pairs mean 4 joints. So here you can see one like less. These joints are 1 time less than the total number of links. So here also similarly. Okay, n value we can get. Now j equal to 4. Okay, 3 revolute and 1 prismatic joint, so total number of joints is 4 here. Okay, and we can see here, okay, 3 revolute and 1 prismatic, so 3 revolute 3 into 1 and 1 prismatic 1 into 1. Okay, so it will come 4. Now here by formula 6 into n minus 1 minus 4. Okay, it will come, you will get the answer. Now in industrial robot has configurations type RRP. How many degrees of freedom does it have and what is the shape of its workspace? So solution is RRP, R, R, P and P. each has 1 degree of freedom. Okay, so total degree of freedom is 3. Now for RRP configuration, it is a spherical sector shaped workspace. Okay, here you can see. So for example, exam tip, it is like in GATE questions on this Greubler formula, degree of freedom calculation and identifying robot configurations are asked frequently. Okay, draw simple sketches to identify the type. Okay, this type of question actually generally asked. So R is revolute joint, P is prismatic joint, R is rotational, this is translational. All type of industrial robots, configurations, parts and application. So Cartesian robot you can see here. The application CNC machine, 3D printers, pick and place, material handling. Parts are base is there, x axis prismatic, y also prismatic, z axis prismatic, end effector, gripper, tools, control unit. Similarly, cylindrical robot RPP. Okay, one revolute, two prismatic joints. Here you can see application is machine loading, okay, unloading, material handling, assembly. This type of cases it is used. Prismatic joint, this is base, this is end effector. Again here it is prismatic. Okay, so now spherical or polar robot RRP. Okay, revolute plus one prismatic joint. So revolute solder joint it is there, and end effector here it is there, prismatic radial movement. Okay, then here revolute base rotation it is there. So application is arc welding, spray printing, material handling. Okay, 2R you can see here and one prismatic. Similarly for SCARA robot, here this is 1R, this is P, okay, and this is 1R. It is used in PCB assembly, screw driving, okay, pick and place, electronic industries. Articulated robot RRR 6 axes. Okay, you can see here this is used welding, painting, assembly, okay, cutting, material handling. Now here parallel or delta robot, parallel kinematic robot, this is used in like parts are here, fixed base, upper arm, lower arm, okay, parallelogram link, end effector actuator, used in high speed pick and place, food packaging, pharma, sorting, inspection. Collaborative robot, okay, usually 6 axes articulated. So here works with human safety, assembly, inspection, machine tending, screw driving. So other important robots like autonomous guided vehicle is there, robotic arm on a mobile base, it can move. Now common end effector is like this gripper, you can see it can grip something, pick and place, means at the end of the robot which are there. So here vacuum, okay, suction cup, vacuum suction cup, like it will stuck with something, then it will pull it and place somewhere else. Then welding torch, Okay, spray gun, screwdriver, these things are there. Okay, thank you for listening me. Hope you have enjoyed this video. Please stay tuned uh, for future videos. Thank you and prepare well.